Let us wait for a couple of minutes so that everyone will log in. By the time, let me just discuss some questions which Vaishnav has sent. You have sent a lot of questions, no, yaar?
Sir, few questions, sir, which were typical.
They are not at all typical.
So some were, sir.
बहुत सारे हैं. We'll see at the end.
Sir,
Yes,
sir, can I also share my questions which I don't,
you
which
can share, but but if there are many questions, I cannot help out but discuss at the end of the class.
so 5 or 6.
वहाँ पे भी 7 or 8. हाँ, 8, 6 here only 20 questions will become. No, you send it. I'll try sharing the answers.
So could you
Okay.
explain, in the meantime, could you explain that question, sir, in which we have to find...
We'll start. We will start again.
Okay, sir, sure.
Right, because right, so we have some amount of questions to be discussed in work, energy, and power. We'll quickly complete these questions again. So probably at the end, which are difficult, we'll try to discuss those. Okay. So A bar is given, B bar is given. They're asking us to find the component of B bar along A bar. Okay. So what will be component of B bar along A bar? Always remember component of B bar along A bar will be given as B cos theta in magnitude again. And how can I write cos theta as? I can write cos theta as A bar dot B bar divided by magnitude of A, magnitude of B, which I can also write it as A bar dot B bar divided by A into B. What we can cancel out? B and B will get cancelled out. So what would be the component of B bar along A bar? It is basically B cos theta. I can give it as A bar dot B bar divided by magnitude of A. Now, whenever two vectors are given, what will their dot product be? We are aware directly. We can write ax bx plus ay by. Yes or no? What we can write this as? We can write it as ax bx plus ay by divided by what is magnitude of a? It will be given as ax square plus ay square. So what is x component of a here? 3. What is x component of b? 1. Y component of A 4, Y component of B 2, divided by under root of, you can write 3 square plus 4 square. So how much is this turning out to be? 3 plus 8, you will get it as 11, divided by 9 plus 16 will be root 25 you are going to obtain. So the answer should be 11 by 5 units. Clear? Component of B bar along A bar will be B cos theta. And if they are also asking direction, because it is along A bar, I will write A cap as the direction. Suppose if they are asking you component of A bar along B bar, then you will write what would be the component, what will the answer be? Component of A bar along B bar will be A cos theta in magnitude. Because it is along A bar, you will write the unit vector as B cap. Clear? Understood? Yes or no? Is that clear? That is how
Yes,
we
sir.
find component of A bar along B bar or B bar along A bar. A force is given, right, acts on a body for 2 seconds and produces a displacement. Displacement is given. So from displacement, can we find out the velocity? Because they're asking us to calculate power, and we know power is given as dot product of force and velocity. So how can we write velocity as? I can write it as s bar divided by t. So what will be dot product now? Again, you have x component, y component, z component, x component, y component, z component. If I do f bar dot s bar divided by t, you can take f bar dot s bar will be 1 into 2 plus you will get 2 into 3 plus 2 into 1 divided by what is the time? 2 seconds they have given. So 2 plus 6 will be 8. You will get it as 10 divided by 2. How much will be the power beta here? 5 watt would be the power. We have already discussed this case also. Right? Instantaneous power, if they are asking, instantaneous power will always be given as dot product of force and velocity. Power in general is rate of doing work again, dw divided by dt. So f bar dot v bar will be the power over here. Is that clear, everyone? Question, let us see. In a ballistic demonstration, a police officer fires a bullet of mass 40 gram with speed 200 meter per second on a soft plywood of thickness 4 centimeters. The bullet emerges with only 25% of its kinetic energy. The emergent speed of the bullet is how much they are asking. So very simple logic again. He is firing a bullet with speed 200 meter per second, right? It is coming out with only 25%. So what is the final kinetic energy here? It is 25% of initial kinetic energy. It is 25% of initial kinetic energy. What is the meaning of 25%? It is 25 by 100 into initial kinetic energy, which I can write it as initial kinetic energy divided by 4. So what is final kinetic energy? I can write half mv square will be equal to 1 by 4 into, initially you can say it is half mu square. What we can cancel out? Half m will get cancelled out. V square value will get it as u square divided by 4. So what will you get V value as? You will get it as u divided by 2. How much is the initial speed with which it is being fired? 200 divided by 2. You will get it as 100 meter per second. Clear? Understood? In a ballistic demonstration, a police officer is firing a bullet with speed 200 meter per second and into a soft plywood. So what is that plywood doing? It has some thickness 4 centimeters, so it is going to retard the bullet again. So after it comes out of the plywood, it has a speed of 25. It has kinetic energy which is 25% of initial kinetic energy. So speed will be half of the initial speed. Clear, all of you? Yes or no, everyone? I hope it is clear. Next, A bar is given as m into B bar plus C bar, guys. They're asking us to find what is m value here. So how will you write m value? I can write m into B bar as A bar minus C bar. Now what I'll do dot product of B bar on both sides, guys. So what are we going to get? You see, if I do dot product, B bar dot m into B bar should be equal to B bar dot A bar minus C bar. So what will I get this as? I'm going to get it as m is a constant value. I'll get m into B bar dot B bar should be equal to B bar dot A bar minus B bar dot C bar. Distributive law again. What is B bar dot B bar? What is the angle between B bar and B bar? It is 0 again. So what we can write? It will be B into cos 0. Right? B bar dot A bar can also be written as A bar dot B bar. B bar dot C bar, anyhow, I can write it in the same manner. So what are we going to get here? B into B will be B square. Right? So what will our M value be, beta? It will be A bar dot B bar minus B bar dot C bar divided by B square. This will be the scalar value of M. Clear, everyone? So basically I wrote M into B bar from the given equation. We got M into B bar as A bar minus C bar. What did we do from this? We just, on both sides, we have done dot product with B bar. So if you solve that, you will be getting it as A bar dot B bar minus B bar dot C bar divided by B square. Clear, all of you? Right. Next question you see. Ability to do work is called energy. Is this correct statement? Yes. Energy and power are scalar quantities. Yes, both are scalar quantities. So what is the situation? Here both A and B will be correct statements. Next. What is given to us, guys? Velocity versus time graph is given. Moving in a straight line. The mass of the particle is 2 kg. Work done by all forces acting on the particle in time interval 0 to 10 seconds they are asking. Okay, now you see, we know work energy theorem. We can solve the question easily by using work energy theorem. What is work done by all forces, Beta? Work done by all forces will be change in kinetic energy of the system. Change will always be final minus initial. So what I can write here, half into mass, let us say, is m, v final square minus half m into v initial square. So if I take m by 2 common, I'll get it as v final square minus v initial square. Right? So m value will be how much here? 2 divided by 2. If you look at the graph, after 10 seconds, what is the velocity, beta? Minus 10. So I can write minus 10 square minus, Initially, what is the velocity? 5 meter per second. So you can write it as 5 square. So what will I get? This is 100. 100 minus 25, you will get it as 75 joules beta. So how much work is going to be done? 75 joules of work will be done by all forces if the velocity versus time graph is given like this. And what is the concept that we are using? We are using work energy theorem. Work done by all forces will be change in kinetic energy of the system. Clear, everyone? Yes or no? Right. Next question, let us see. A uniform rod is suspended from one end. When it is displaced through 60 degrees from downward vertical, the change in potential energy is U. The further change in potential energy when it is displaced further 30 degrees, they are saying. Again, very important logic, guys. So we have a rod, something in this manner initially. It is hanging like this. Right? What we have done? We have displaced it by 60 degrees. By how many degrees we have displaced? We have displaced this by 60 degrees, guys. This is the situation. So initially, can I concentrate the whole mass at its center? Yes or no? Now, again in this situation, again can I concentrate the whole mass at its center only or not? Yes. So initially, let us imagine the entire mass can be assumed here. So I'll assume this to be our zero potential energy level. Right? In the same manner, right? When it is raised by an angle, how much? Here the angle is given as 60 degrees beta. In that case, what will happen? The center of mass is going to move ahead, guys, or it will just shift upwards. So from here to here, you see what is the distance? From here to here, what is the distance? It is L by 2. Yes or no? From here to here, it is L by 2. This is 60 degrees. What will I get from here to here? From this to this, you will get it as L by 2 cos 60. From here to here, again, it is L by 2. So what will I get this distance as? L by 2 minus L by 2 cos 60, you will get beta. Is that clear? Now what they are saying? Further, if I am rotating it by 30 degrees, means overall, will I rotate it by 90 degrees or not, guys? So overall, I have rotated by 90 degrees. Then what is the change in potential energy they are asking? So further, I have rotated by 30 degrees. So you see, this is our first position. This is our intermediate position. This is our third position. Uniform metal rod is suspended from one end. When it is displaced through 60 degrees from downward vertical, the change in potential energy is U. Can you define potential energy at a point? Obviously not. Now in the next case, can I concentrate the whole mass at the center here or not? So these are the three positions of the uniform rod, guys. Initially it is vertical. Then in intermediate position, it is making an angle. It is making an angle 60 degrees with the vertical. Now in the third case, it is becoming horizontal, guys. So we have three different positions of the rod. Because it is uniform rod, we can concentrate the entire mass at its center. So from here to here, it will be L by 2. From here to here also L by 2. From here to here also L by 2. So from here to here, if it is L by 2, I'll get this as L by 2 cos 60. I'll get this as L by 2. So can we define potential energy at a point? No, we can define only its change, guys. So assume that this is zero potential energy level. Okay. Now, what is the change in potential energy between first and second case if I take? What is change in potential energy? It is final minus initial. Initially, I have already considered to be on zero potential energy level. You will get it as 0. This will be final potential energy. What is final potential energy? Is this point lying at a certain height above zero potential energy level? Yes. So what will I get? Mg into L by 2 minus L by 2 cos 60. So what will this be? Mg into L by 2, you can take common. 1 minus cos 60. Cos 60, you know it is 1 by 2. I'll get this as mgl divided by 4. So what they have given? They have given the change in potential. This change in potential energy, they have mentioned it as U. Now what they are asking is further change in potential. How much extra change you will have if it is further displaced by 30 degrees. Now what I'll do, I'll apply between first position and third position, guys. What are we going to do now? We are going to apply between first position and third position. So again, what is change in potential energy here? Final minus initial. You know, initially it is going to be 0, right? So it will be final again here. So what will be in third position? At how much height it is above it? It is at a distance L by 2 above. What I'll write? mg L by 2 you are going to get. So already mg L by 4 is u. If I multiply this by 2, will I get this or not? Will this be 2u beta? So how much extra change we have? Extra change in potential energy if they're asking. The further change they're not asking simply change, they're asking further change. So what is the further change beta? If they are asking us to calculate the further change, so from 1 to 2 change is u, from 1 to 3 change is 2u. So from 2 to 3 what is the further change? It will be 2u minus u. You will get it as u, guys. Clear everyone? Understood all of you? Yes or no? Very important concept based on potential energy. Can you define potential energy? No, we cannot define potential energy at any point. If we are defining potential energy at a point, it has to be with respect to some zero potential energy level. Clear everyone? Yes or no? You understand all of you? Constant force is applied. Am I audible? Hello.
Yes, sir.
A constant force is applied on a 10 kg mass at rest. The ratio of work done in first second, second second, and third second they're asking. Okay. What we are applying? Constant force is applied on a 10 kg mass. Okay, let us imagine. So initially at t is equal to 0. What is the speed? U value will be 0. What is the meaning of first second? From 0 to 1 second is called as first second, guys. What is second second? From 1 to 2 second is called as second second. What is third second? From 2 to 3 is called as third second. Let us imagine the force which is being applied is F. Okay, mass is given as 10 again. This is a constant force. So implies what will be the acceleration beta? You will get it as F divided by 10. Yes or no? Now, can I apply V bar will be equal to U bar plus A bar into T? What is initial velocity? 0. What will I get V bar value as? A bar into T I am going to get. So after 1 second, what will its speed become? It will become F by 10 into 1. After 2 seconds, what will its speed become? F by 10 into 2, which you will get it as 2F divided by 10. After 3 seconds, what will it become, beta? It will become 3F divided by 10. They're asking what is the ratio of work done again, right? In this is our first second. From 0 to 1 will be first second, right? In the same manner, from 1 to 2 will be second second. From 2 to 3 will be third second. What I can do again, work done by all forces will be equal to changing kinetic energy will apply. Work energy theorem will apply, guys. So what I will get work done in first second? Initial kinetic energy anyhow 0. What are we going to get? Half into finally half into 10 into F by 10 whole square. Yes or no, all of you will get it as F square divided by, so 10 and 10, 20 you will get in first second. What is work done in second second, beta? Very important. Second second means initially it is starting with this speed. Now it has this much speed. What I will write? Half into 10 into, finally the speed became 2F by 10 whole square minus, or I'll just write it towards little bit left side, guys. So what is the work done in second second now? Second second means from 1 second to 2 seconds, guys. So half into, mass is anyhow 10, speed is 2F divided by 10 whole square minus half into 10 into, what is the speed at 1 second? F by 10 whole square. So what will you get this as? 4F square by 20 you will get. This is 4f square by 20 minus this, I'll get it as f square divided by 20, which overall will be 3f square divided by 20. So in first second I got the work as f square by 20. In second I got the work as 3f square divided by 20, guys. Let us try to find out what is the work done in third second. So in order to find out work done in third second, what will I do? Again, change in kinetic energy will apply. After 3 seconds, what is the speed here? 3f divided by 10 whole square. Minus, after 2 seconds, what is it? 2f divided by 10 whole square, guys. So what are we going to obtain now? This will be 9f square divided by 20 minus, we got this as 4f square divided by 20, which will turn out to be 5f square divided by 20. So what is the ratio of work done? They're asking us to find out ratio of work done in first second to second second to third second. So what is this beta? It will be in the ratio of f square divided by 20 we have. Then we have 3f square divided by 20. We also have 5f square divided by 20. So what will the ratio be? It will be in the ratio of 1:3:5, guys. It will be in the ratio of what? 1:3:5. So a constant force has been applied, right, on an object of mass 10 kg. They're asking what is the work done in first second to second second to third second. So what we can do in this situation? Because of this constant force, we are going to have constant acceleration. So I have found out the speed after first second, or speed after 1 second, 2 seconds, and 3 seconds. What is the meaning of first second? From 0 seconds to 1 second will be first second. From 1 second to 2 seconds will be second second. From 2 seconds to 3 seconds will be third second. So I have utilized work done will be change in kinetic energy of the system. Clear, everyone? Yes or no? Right. What can internal forces change? I have told you many times. Internal forces will cancel out each other, guys. So internal forces will not affect the motion of the object. However, they can change the kinetic energy, guys. Internal forces can change the kinetic energy of the system. Is that clear, everyone? So or no? Hope it is clear. Let us see next question. A person of mass 50 kg standing on a smooth horizontal plane of ice throws a body of mass 5 kg with velocity 10 meter per second. Then they are asking the total kinetic energy of the person and the body is. A person of mass 50 kg standing on a smooth horizontal plane. So we have some ice beta. It's a smooth surface. So initially you see person is standing on it, and he has some body in its hand. So what is he doing now? Initially person is just standing. So is there any momentum to the person? No. Is there any momentum to the body? No. So initial momentum is 0. This entirely is one system, guys. Okay, now what has happened? What did the person do? It has thrown this object with a speed, let us say 10 meter per second, along positive x direction. Let us imagine person mass is capital M, object mass is small m. So initially, was there any momentum? No. But after the person is throwing the block, does block have momentum in x direction? Yes. Should system have any momentum? No. Initial momentum is 0 because there is no external force, guys. Final momentum should also be 0. But finally, as the object or the person is throwing the object, this object got some momentum in positive x direction. So in order to cancel out that momentum, guys, the man is going to move in which direction? Backward direction. Clear, all of you? What are we going to use here? Here initial momentum is how much? 0. So as, see, this is entirely one system. So whether the person is throwing the body or body is pushing the person, they all happen internally only, guys. So as net external force happens to be 0, what we can conserve? Momentum will remain constant. Right? Momentum is remaining constant means final momentum should be equal to initial momentum. Right? So what is final momentum? Small m mass is moving along positive x direction. Capital M mass is moving along negative x direction. initial momentum should be 0 here. What I'll get, m into v should be equal to m into small u. V value will be small m divided by capital M into u. Small m value is 5, capital M value is 10. Sorry, 50. What is the speed with which it is throwing? 10. What I'll get this as beta? I'll get it as 1 meter per second. Yes or no? So as soon as the person throws the object in forward direction, he will get recoiled in backward direction. They're asking the total kinetic energy of the person and the body is how much. So what is the total kinetic energy? It will be sum of initial kinetic energies. So you can write half into m into 1 square plus half into small m into 10 square. Okay, half into you can write 50 plus half into 5 into you can take it as 100, guys. Right? So how much will I get this as? This will be 25 and this will be 250. So overall I'll get it as 275 joules, guys. Clear, everyone? Yes or no? Is that clear to all of you? Let us move to the next question. Particle moves in a straight line with retardation proportional to displacement. Its loss of kinetic energy for any displacement x they are asking, guys. So what is given here to us in this question? Very important, guys. Particle is moving in a straight line with some retardation proportional to displacement. So what I can write here, A will be proportional to minus x. Okay, they're asking loss in kinetic energy for any displacement x is proportional to. So I can write, if you remove proportionality sign, I'll get it as minus k into x. Now because acceleration is varying with position, guys, I can write acceleration as v into dv by dx will be minus k into x beta. So what are we going to do here? V into dv can be written as minus k into x into dx. Differentiation is there. In order to remove differentiation, what we are going to apply? We'll apply integration. So what is integral v dv beta? So I can consider from some here, if you substitute the limits, from some x initial to x final, from some v initial to v final. So what will I get integral v dv as? Integral v dv will be v square divided by 2, as you all may be aware of already. Right, you are going to get it as v square divided by 2 from where to where? From initial to final. Should be equal to minus k is common. What is integral x dx? X square divided by 2 from where to where? X initial to x final. So let us imagine x initial is 0, x final is how much beta? X. Clear all of you? Now what are we going to get? V final square divided by 2 minus v initial square divided by 2 should be equal to minus k into, you will get it as x square divided by 2 only. Yes or no? So if I substitute if I multiply with mass, what will I get if I multiply with mass? I'm going to get half into m into v final square minus half into m into v initial square should be minus mk into x square divided by 2. So what is this? This final kinetic energy minus initial kinetic energy will be equal to, what are we going to get? Minus mkx square divided by 2. Or from this I can write initial minus final will be equal to mkx square divided by 2. So what is initial minus final? It is loss, guys. So loss in kinetic energy, as you can see, it is directly proportional to x square, guys. Right? It will be directly proportional to x square. Clear, everyone? Yes or no? Is that clear, all of you? Now what they have given, a body is revolving in a vertical circle with constant mechanical energy. Right? They are saying the speed of the body at the highest point is root 3 rg. Then what is the speed at the lowest point? Okay. If we take highest point, at highest point, what is going to happen? We take vertical circular motion, guys. Highest point. Very simple logic again. I'll just show it here. One end of the string is fixed. The other end is connected to a certain object, guys. And this object is now made to rotate in a certain vertical plane. It is now made to rotate in which plane? In a vertical plane. So you can consider center to be somewhere over here. Right? Now this would be our highest position. Right? This will be our horizontal position. Right? And this would be our any arbitrary position, guys. We can take this happens to be our any arbitrary position. So let us say speed here given is v1, right? Here you are going to get speed as v2. Here you are going to get speed as v3. At any arbitrary position, let us consider speed is v. At highest point, what are the forces you see? At highest point, weight will act. Yes or no? Mg is going to act, but apart from that, tension will also act, guys. Right? Tension at highest point you can consider. Here what will happen? Weight will act downwards, but tension is going to act which direction? Tension at lowest point will be like this. Clear? So now whenever object is performing circular motion, what should be there? There should always be a force directed towards center, guys. So here there should be a certain centripetal force. Which force should be present, beta? At any point you may take, you should have a force directed towards the center called as centripetal force, guys. Now usually in critical condition, tension at highest point will be 0. Speed at highest point, you will get it as root over gr. But here, the speed at the highest point, if you see, is given as root over 3gr. It means tension is non-zero. It is not a critical condition. When will this be critical condition? If the speed at the highest point is equal to root gr. Here you see, is speed given as root gr? No. In critical condition, we can remove tension, guys. Tension can be cancelled out. Only weight will give us necessary centripetal force. But is this our critical condition? No, it is not our critical condition, guys. So what we can write in this situation? What are we going to get here? I can write tension at highest point plus mg will give us necessary centripetal force. Okay. So tension at highest point plus mg. What will it be? mv square by r are we going to get or not? Yes. So you can write it as mv square divided by r. So tension at highest point plus mg if I take. What is v value here? At highest point, what is v? 3rg. If I do v square, you will get 3rg by r again. So I am going to get it as m into v square by r. If I do, guys, you will get it as r divided by how much? V square value is 3rg, no? So you will get it as 3g, guys. Yes or no? So what is the tension at the highest point? You will get it as 2 mg. Now, as I also said you, whatever may be the condition, guys, right? What will be the situation here? Tension at lowest point minus tension at highest point will always be equal to 6 mg. So what is tension at lowest point now? It will be 8 mg. Are we going to get or not? Yes. Now, whenever object is performing circular motion, right, will it execute or will it experience a force directed towards center called a centripetal force or not? So at lowest position, what will be the equation for centripetal force, guys? At lowest position, right? Always remember at lowest position you will get TL minus mg will be equal to necessary centripetal force at the lowest point. Now, tension at lowest position we got, which is 8 mg minus mg will be equal to, what is the centripetal force here, beta? Can I write it as mv1 square divided by L or not? So 7 mg value will be mv1 square divided by L. So what are we going to get v1 square value as? I'm going to obtain v1 square value as 7gl. v1 value will be root over 7gl. Is that clear? We need to know how to write the equations for circular motion, guys. How do you write the equation for circular motion? Very simple. Whenever object performs circular motion, there should be a force directed towards the center, guys. And it is called a centripetal force. Can it exist on its own? No, it can never exist on its own. It has to be provided. So here, who is providing the centripetal force? The resultant of tension and weight. In all cases, the resultant of tension and weight will provide necessary centripetal force. Clear, everyone? Yes or no, everyone?
So you said the point in the starting. So what was it?
Which point?
So regarding that tension alone is not providing the, it can't be root 3.
Oh, see, here at highest point, both weight and tension are directed towards center. So both of them will be helpful in providing centripetal force. But instead of saying both of them are helpful, I can say only one of them may provide. So let us say if tension is providing, it means weight should be removed. Do you have the ability to remove weight?
No, sir.
No. So it means weight cannot be removed. So automatically, by convention, what I can say? Tension should be removed. So that is critical condition. So in critical condition, at maximum height, what is going to happen? Speed will be root gr. And at maximum height, mg alone will give us necessary centripetal force, guys. Mg alone will give us necessary centripetal force. Is speed at highest point given as root gr? No, it is given as root 3 gr, guys. So I can consider or conclude that tension will not be zero at the highest point. Understood, everyone?
Yes, sir.
Let us see. So answer should be root over 7 gr, which we have got, I guess. Next. Collision in which the relative velocity of approach before collision is equal to relative velocity of separation. So what is coefficient of restitution, beta? It is given as ratio of velocity of separation to velocity of approach. Yes or no? Yes or no, guys? Now what they are saying, what is that collision in which relative velocity of approach before collision is equal to relative velocity of separation after collision? Are these both equal or not? What will I get E value as? 1. So in which case are we going to get E value as 1, beta? You can consider in elastic collision, you can consider. Clear, all of you? And always remember, in vertical circle, as I have already told, lowest position tension will be maximum. Highest position tension will be minimum. Understood, everyone? Is that clear? Let us see this question. A particle of mass m moving with velocity u collides elastically head-on with particle of mass 2m at rest. They're asking the collision. After the collision, the heavier particle moves with the velocity how much? Okay. So let us say heavier particle means it is second object or not, guys? Yes or no? They're asking collision. After collision, the heavier particle moves with. So which is heavier mass here? Second mass is heavier mass. So how will I find final velocity, beta? V2 bar, as I said, it will be given as m1 into, because it is a elastic collision, E value will be 1, guys. So I can write it as, if not, you can take it like this, m1 into 1 plus E divided by m1 minus m2 into u1 bar plus m2 minus em1 divided by m1 plus m2 into u2 bar. Clear, all of it? This is the final velocity of the second object. Now you see, second object initially is rest. Initially is at rest. So u2 bar will be 0 or not? So anything multiplied with this will be 0. So what I am going to be left out with? Because elastically is given. What is E value? 1. So what are we going to get V2 bar as, beta? First mass is given as m, 1 plus 1 divided by, first mass is given as how much? M. This is plus, guys. Second mass is given as 2m. What is initial speed? I think it is given as u only, guys. Yes or no? What will I get? 2u by 3 I am going to get, guys. The answer as. I'll obtain this as 2m divided by 3m into u. So you will get alpha particle as 2 divided by 3 into u. Clear, everyone? What have we applied? We have simply applied the final equation. What are the final velocities? V1 bar will be given as m1 minus em2 divided by m1 plus m2 into u1 bar plus m2 into 1 plus c divided by m1 plus m2 into u2 bar. In the same manner, v2 bar formula also we can write, guys. So here what they have given? They have given the second mass is at rest. So what I can say, u2 bar will be 0. So like this we will be able to calculate. Is that clear, everyone? Yes or no? Any doubt in this? Everyone, guys. Clear, all of you? Right. Let us see next question. A particle is acted upon by constant power. Which of the following quantity remains constant, it seems? Okay, power is constant, guys. What we can consider there? Power is constant, it seems. So if power is constant, can I write dw divided by dt? Will it be equal to constant? Now what is work done? Will it be change in kinetic energy of the system or not? What I can write this work done? I can also write it as dk by dt. So what is the situation here, guys? What is the meaning of d by dt? It is rate of change with respect to time. So when power is constant, I can say rate of change in kinetic energy will remain constant. Clear, everyone? Yes or no? I hope it is clear. Next question, if you see, potential energy of a particle is given. So potential energy is given already. It means potential energy is being defined. Whenever potential energy is being defined, which type of forces are acting? Conservative forces. So is there any relation, beta? Yes, there is a relation which is given as minus of du divided by dx. So what we can write here, minus of d by dx of this, you can write it as 2x square minus 8x, right? So what will I get f value as? I'll get it as d by dx of 8x minus 2x square. So again, what will this be? I can write it as derivative of 8x minus derivative of 2x square. So you'll get it as 8 minus 4x. They're asking the force on the particle will be 0 at which position? So this is our force, guys. Now what they're asking for force to be 0, for F to be 0. What I can do, beta? Can I simply equate it to 0 or not? 0 will be 8 minus 4x. You will get 4x value as 8, implies x value will be 2 meters, guys. Clear, everyone? Understood, all of you? Whenever expression for potential energy is given, it means potential energy is being defined. And potential energy can only be defined in conservative fields, guys. So if expression for potential energy is given, it means it is defined. And which forces will be there? Conservative forces are going to be there. Is there any relation between conservative force and potential energy? Yes. So from there we can obtain, right? The force will be 8 minus 4x. And where will force become 0? At x value equal to plus or minus 2. Understood, everyone? Yes or no? Is that clear, all of you? Just give me a minute, guys. Am I audible, everyone? Right. Let us see the next question. They have given us a force is acting on a mass. The change in kinetic energy of the body when it moves from 0, 1, 2 to 2, 0, 3. So as you can see here, force is varying only with x, guys. It is not varying with y. It is neither varying with z here. So what we can write work done? I can write work done as integral of fx dx, guys. From where to where? From some x initial to some x final. So what we can write work done as integral of, what is the variation of force here? 3x square plus 2x plus 1 into dx. From where to where, beta? X coordinate is varying from 0 to 2. So I can also write this as integral of 3x square dx plus integral of 2x dx plus integral dx. From where to where? 0 to 2, 0 to 2 and 0 to 2. So 3 is common. Integral x square I am going to get it as x cube divided by 3. From where to where? 0 to 2 plus 2 is common. Integral x I will get it as x square by 2. Again from 0 to 2. Integral dx will be x from where to where? 0 to 2. So what is the total work done over here? So I can write it as, I'm directly writing it 3 into 2 cube by 3 minus, so what we can cancel out here? 3 and 3 will get cancelled, 2 and 2 will get cancelled. So what will be left out? 2 cube you will get, which is 8, plus 2 square you will get, which is 4, plus 2 you are going to get, guys. So what is this? 14 you will get. 14 joules is the work done. They're asking us to find change in kinetic energy. And we all know what is the work done by all forces. Work done by all forces will simply be change in kinetic energy of the system. So change in kinetic energy will also be how much, beta? 14 joules, guys. Clear, everyone? Here force is varying only with x, guys. Yesterday I've told you we can write work done as integral fx dx plus integral fy dy plus integral fz dz. But if it is varying only with x, then I'll write integral fx dx. If it is varying only with y, I'll write integral fy dy. If it is varying only with z, I'll write integral fz dz, guys. Yes or no? So what we can consider in this situation, the work done, if we just perform integration, I am going to get the answer as 14 joules. This work done will be completely utilized in changing the kinetic energy. Clear, all of you? Yes or no? If the force acting on a body is inversely proportional to speed, it seems, what will happen to kinetic energy? They are asking. Force is what, beta? Inversely proportional to speed, right? So you can take F is inversely proportional to speed v. So what we can write, if I remove proportionality constant, will I get k by v? What will I get? F into v will be constant. What is this F into v, beta? Is it power or not? Yes, it will be power, guys. So I am going to get F into v will be constant. Implies power is a constant value. So if power is a constant value, or if not, you can directly write here. F into v we are going to get constant again. How can you write force as, beta? I can write it as mass times of acceleration into v will be equal to constant. Again, I can write a into v will be k divided by m. Mass anyhow will be a constant value. So overall this will be constant. Now how can I write the acceleration as, because they're asking in everything in terms of time here. So I can write acceleration as dv by dt, guys. Should be equal to k divided by m. Okay. So what I can write? I'll write v into dv will be equal to k into or k by m into dt. Differentiation is there. In order to remove differentiation, going to apply integration. What is integral v dv? Obviously, it will be v square by 2, which will be k by m. Integral dt will be t, guys. So I'll get half mv square will be equal to k into t. What is this half mv square? Is it kinetic energy or not? Which will be equal to some k into t. So I can say kinetic energy, if force is inversely proportional to speed, then kinetic energy will become directly proportional to time. It is linearly related to time, guys. Understood, all of you? Why directly proportional to x? Mean follow a straight line graph. Straight line is nothing but it follows a linear variation. Understood, everyone? Yes or no? Is that clear? Now, a billiards player hits a stationary ball by an identical ball to pocket the target ball in a corner pocket that is at an angle 40 degrees with respect to the direction of motion of the first ball. So let us say we have first ball like this. Second ball is at rest, guys. So how is first ball moving? Imagine that first ball is moving in this manner. A billiards player hits a stationary ball by an identical ball to pocket the target ball in a corner pocket that is 40 degrees with respect to the direction of motion of the first ball. Assuming the collision is elastic, you see, both identical balls are there. One object is at rest, is colliding obliquely, guys. And assuming the collisions are elastic, friction and rotational motion are not so important. Angle made by the target ball with respect to the incoming ball, they are saying. Okay. So what they are saying, we have a corner somewhere over here by an identical ball to pocket the target ball. So a billiards ball hits the stationary ball by an identical ball to hit the target ball in a corner pocket. What is that is at an angle 45 degrees with respect to the direction of motion of first ball. So this is our first ball. Let us say this is the target ball, guys. Okay. Assuming the collision, the angle made by the target ball with respect to the incoming ball they are asking. This question doesn't make sense actually because so this is your incoming ball. Yes or no? And this is your target ball. Now what will happen here? Both the objects are identical and they are undergoing elastic collision obliquely, guys. Then I've told you how will they move? They'll move mutually perpendicular to each other or not? Yes. So please see this target ball. I have to target it into a corner. And where is that corner, beta? That corner is making an angle 40 degrees. This is the motion of the target ball now. So what will happen to the incoming ball? Will the incoming ball, will it move in this manner perpendicular to each other or not? Yes. So how much will this angle be, beta? This angle will be 50 degrees now. Okay. So billiards player hits a stationary ball by an identical ball to pocket the target ball in a corner pocket that is at an angle 40 degrees with respect to the direction of motion of first ball. Assuming the collision is elastic and friction and rotational motion are not important, angle made by the target ball with respect to the incoming ball they are saying. So this is incoming ball. Now I want to send this target ball to a target in this manner. Now after collision, how will incoming ball move? Incoming ball and target ball will be moving perpendicular to each other, guys. So answer should be 90 degrees over here. Option is not given. You keep it aside, guys. Clear? Understood, everyone? If two balls are there, that is secondary. So I'm not able to visualize the question also. Let us see the next question. A force 40 Newton is applied. The body gains a kinetic energy 20 joules after it moves a distance of 2 meters. What is the frictional force they are asking? Okay. Now what is this situation here? Again, I'm going to use work energy theorem, guys. Force is there is some applied force, there is some frictional force also. Now when it is moving a distance of 2 meters, there is a gain in kinetic energy of 20 joules. So what I can use, beta? Work done by all forces will be equal to what? Change in kinetic energy. So I can say work done by the applied force as well as the work done by friction should be equal to what? Change will always be final minus initial. So what is the work done by the applied force? It is a constant force and the object is moving by a distance 2 meters, guys. So this you can write it as 40 into 2 plus work done by friction. Now, body is gaining kinetic energy body gains a kinetic energy 20 joules after it moves. So what is this meaning? K final minus K initial, if you do, you'll get it as 20. So 80 plus work done by friction will be equal to 20. So what is the work done by friction, beta? Work done by friction, you will get it as minus 60. Right? Suppose if friction is also constant, implies I can write F into 2 will be equal to minus 60. So what is the value of friction here? Minus 30 Newton. So what is the meaning of minus sign here? It will act opposite to the direction of motion, guys. How much friction will be acting? 30 Newton frictional force will be acting. And what is the work done by frictional force? Work done by frictional force will be minus 60 joules, guys. Understood, all of you? Yes or no? I hope it is clear. Next question, let us see. Angle between I cap plus j cap and j cap plus k cap will be. How do you find angle, beta? We know dot product of two vectors is given as magnitude of A, magnitude of B, cos theta. So what will cos theta formula be? A bar dot B bar divided by magnitude of A, magnitude of B. Yes or no? Now what do you get by performing dot product of these two? I into, there is no I here. I dot j will be 0. So what I am going to get here, guys? I plus j, right, dot j plus k divided by magnitude of A bar will be under root of 1 square plus 1 square. Magnitude of B bar will also be under root of 1 square plus 1 square. I dot j 0. I dot k also 0. J dot j 1. So in numerator will get 1. Root 2 and root 2 will be 2, guys. So cos theta will be 1 by 2. Implies what will theta value be? It will be 60 degrees, guys. So what is the angle between I plus j and j plus k? It will be 60 degrees. Understood, all of you? Yes or no? Next question. A body is being raised to a height h from surface of the earth. What is the sign of work done by applied force and gravitational force? See, you are raising the height. Sorry, you are raising the object to a certain height. Means displacement is in upward direction. But gravitational force will act in downward direction. So what is the work done by gravitational force here? Gravitational force will be doing negative work. In order to raise it, I need to pull this object in upward direction. So force, applied force is in upward direction, displacement is also in upward direction. So work done by applied force will be positive. So positive and negative should be the answer in this case, guys. Work done by applied force positive, work done by gravitational force will be negative. Clear, everyone? What they have given in this question is a block of mass 5 kg is moving in x direction with a constant speed. Now it is subjected to a retarding force during its travel from 10 meters to 20 meters. What is its final velocity? They are saying, guys. Okay. So you see, very basic logic, guys. Very important concept again. It is there in NCRT also, similar kind of question. Similar kind of question is there in NCRT maps also. Akash students, guys. Block of mass 5 kg, let us say. Here you have taken a block. It is moving with some speed, guys. Let us say it is moving with some speed u. Will continue moving till where? Till x is equal to 10 meters. Now from x is equal to 10 meters to x is equal to 20 meters. Right? This is x is equal to 0, x is equal to 10, x is equal to 20. Now while it is moving from here to here, it is subjected to some retarding force, guys. From here to here, there is no retarding force. So whatever is the speed here, just before 10 meters also it will be u only. But now you have retarding force. What will this retarding force do? It will reduce the speed. How will the object move? In the direction of velocity with decreasing speed only. Here velocity will be v, which will be less than u, guys. So what are they asking? It is moving with constant speed. So here u value is given, which is given as 20 meter per second, right? And it is subjected to a certain retarding force minus 0.2x during its travel from 10 meters to 20 meters. Final velocity will be how much they're asking, nearly. Now, what will be the forces that are going to act? So although we got this as x is equal to 10, what will be the forces that are going to act, guys? First and foremost, will weight act? Where is weight acting? On the ground. Will ground keep quiet? No. What will it give? Normal reaction. Is there any other force given? Retarding force is given. How is the displacement? In x direction. Weight is acting in y direction. So will there be any work done by weight? No. In the same manner, displacement is along x direction. Where is normal reaction acting? In y direction. Here force and displacement are perpendicular. Will there be any work done by normal reaction? No. Who will do the work, beta? Here you will have only work done by the retarding force. This will be equal to change in kinetic energy of the system. Now, is this force constant or variable? As you can see, it is a variable force. So what we can apply? Integral of, because it is varying with x, integral of fr into dx. From where to where? From, it is moving from 10 meters to 20 meters. Should be equal to final kinetic energy minus initial kinetic energy. So what are we going to get, beta? Integral of, here I can take it as minus 0.2x into dx. From where to where? From 10 meters to 20 meters. Should be equal to, I can write it as half into m into, you will get v square minus u square value is already given as 20 square beta. Okay, so what are we going to get? Minus 0.2, you can just remove it. What is integral x again? X square by 2 you will get. So I can write minus 0.2 into x square divided by 2 from 10 to 20 should be equal to, again m value is anyhow 5 by 2 into v square minus 20 square. Okay, so if I substitute the limits, what I'll get? 0.2 into 20 square is 400. 400 by 2 will be 200 minus 10 square is 100 by 2 will be 50. Should be equal to 5 by 2 into v square minus 20 square. Okay, so what will this be? 150. Yes or no? 150 into 0.2 if I do, I'll get it as near about 30, I guess, guys. Yes or no? 0.2 into 150 will be 2 into 15, which is minus 30. So minus 30 will be 5 by 2 into v square minus 20 square. So minus 60 will get, and 5 ones, 5 6 you can write. So what will I get? V square value as will be 20 square minus 12. So v square value I'll get it as somewhere around 388, guys. So v value will just be near to 20. Okay. So I'm going to get the value of v as approximately 19.7 meter per second. Clear, all of you? Is the retarding force acting from 0 to 20? No. Retarding, so there is no change in kinetic energy while the object moves from x is equal to 0 meters to x is equal to 10 meters. No change in kinetic energy. But from 10 to 20, there is a retarding force acting which is variable in nature. So work done by variable force, you all know it is integral of fx dx will apply. Understood, all of you? Yes or no? Let's see next question. What they have given, force is acting, it maintains its velocity if the rate of change in kinetic energy of the body is 0. What is rate of change in energy? See, basically we know power is given as rate of doing work. And from work energy theorem, we can write work done will be change in kinetic energy. So what is this rate of change in kinetic energy? How much is it given as? 0. And what do we write power as? F bar dot V bar will be 0. If you do dot product of these two guys, what will I get? 3 into alpha 1 into 2 plus minus 2 into 4 should be equal to how much? 0. So 3 alpha plus 2 minus 8 will be minus 6 will be equal to 0. Alpha value will be 6 by 3, which is 2, guys. Understood, everyone? Clear, all of you? Rate of change in energy, rate of change in work, nothing but power. If power is 0, it means I can write F bar dot V bar will be 0. So if you do dot product of force and velocity, we will get alpha value as 2, guys. Understood, everyone? Yes or no? But again, direct question, you see. I've told you this also yesterday. When two spheres of equal masses undergo oblique elastic collision with one of them at rest, right? After collision, how will they move? They will move at right angles to each other. Next case, you see. Power questions are very important, guys, because power questions mostly have been asked in NEET. So I think the trend may continue again. A body is initially at rest. It undergoes one-dimensional motion with constant acceleration. If acceleration is constant, means force is also constant. They're asking what is the power delivered to it at a time t is proportional to. Power delivered, again they're asking. So here we know power is given as what? You know, power can be given as force into velocity. Okay. Here, acceleration is what? Constant. It means, can I say force will also be constant or not? Or basically, you can say force is anyhow constant. So acceleration is constant means dv by dt will be a constant value. dv value will be k into dt. So in order to remove differentiation, what should we apply? Integration. In order to remove differentiation, we should apply integration. Integral dv will get it as v. K is a constant. Integral dt will be t. So v you see is directly proportional to time. And what is force? It is independent of time because acceleration is a constant value. So what will power be, beta? Power will also be directly proportional to time. Direct question again. Power delivered to it at any time will be directly proportional to time, guys. Understood, everyone? Yes or no? I hope you understood it. Right, next case, if you see, they have given us two springs of spring constants. Both of them have same spring constant. They are stretched by force 100 and 200. What is the ratio of potential energy they are asking? Yesterday again we have done this. What is expression for elastic potential energy? Half kx square, or I can write it as half into f square divided by k. Yes or no, everyone? Into k by k if you do. Right. They have given same spring constant for same value of k. What will u be, guys? It will be proportional to f square. So what we can write, u1 divided by u2 will be f1 divided by f2 whole square. So what is f1 here? 100 divided by 200 whole square, which I'll get it as 1 by 2 whole square. The answer should be 1:4, guys. Clear, everyone? So for same spring constant, u will be directly proportional to f square, guys. 1:4 should be the answer for this. What is 1 kilowatt hour they're asking in terms of electrovolt, right? Very important case again. Basically, when I say 1 electrovolt, it is 1.6 into 10 power minus 19 joule, guys. And when I use 1 kilowatt hour, what is 1 kilowatt hour? Kilo means, again I can write it as it is energy again. Kilowatt hour is, so I can write 1 into 10 cube. What can be written as joule per second? Hour, in each hour you'll have 3600 seconds or not, guys. So this will be what, beta? 3.6 into 10 power 6 joules. Okay. Now I want to write it in terms of electrovolt. So how can I write 1 joule as? So I can write it as 3.6 into 10 power 6. 1 joule I can write it as 1 divided by 1.6 into 10 power minus 19 electrovolt. What will this turn out to be? 3.6 divided by 1.6 into 10 power 25 electrovolt you will get. 36 by 16 we can write, which will be 9 by 4 into 10 power 25 electrovolt. I can also write it as 2.25 into 10 power 25 electrovolt. Clear, everyone? I hope it is clear. What they are saying, a ball of mass m collides with a wall with speed v and rebounds on the same line with the same speed. If the mass of the wall is taken infinite at rest, then the work done by the ball on the wall, work done by the ball on the wall, it seems. See, first ball is colliding with the wall. Wall is at rest initially. Now what is happening to the ball? It is moving back. So whether you take initially or finally, is the wallet going to be at rest or not? The ball cannot move the wall, guys. That is the reason work done by the ball on the wall will be 0. Understood, all of you? Yes or no? An object has displacement from position from here to here, it is given, guys, under the effect of a force. So as you can see, it is varying from, so R1 bar is given as I cap plus 2j cap. So I can say its position vectors are, coordinates are 1 comma 2. R2 bar is given as 2i cap plus 3j cap, right? And it has position or coordinates 2 comma 3. What is the force given? It is given as 3x I cap plus yj cap. What is the work done by this force, they are asking? Because it is a variable force, guys, it is the force acting in plane. So how can I write dr bar as? I can write it as dx I cap plus dy j cap. So for small displacement, what is the work done? Let us say it is dw. I'll write it as f bar dot dr bar. So I'll get 3x I cap plus y j cap dot dr bar will be dx I cap plus dy j cap. So what we can get? You will get it as 3x dx plus y dy. This is our small work done. Now, if I want to calculate the total work done, what are we going to get? I am simply going to perform integration. The integral of 3x dx separately plus integral of y dy separately. Here x is the variable and x is varying from where to where? 1 to 2. Here y is the variable. It is varying from where to where? 2 to 3. So 3 into integral x will be x square divided by 2 from 1 to 2 plus integral y will be y square divided by 2 from 2 to 3. What are we going to obtain, beta, from this situation? We'll get it as 3 into 2 square by 2, anyhow will be 2. This will be 2 minus 1 by 2 plus I can write it as 9 by 2 minus 4 by 2. So which turns out to be 3 into 3 by 2 plus you'll get it as 5 by 2, guys. So 9 plus 5 will be 14 by 2. Overall work done will be 7 joules, guys. I've already told you this. If you are writing in plane, the position vector can be given as dx I cap plus dy j cap. And work done in plane can be integral fx dx plus integral fy dy. You can write that, guys. It's a very important question. Work done by frictional force is always negative, it seems. Will work done by frictional force be always negative? This also I have told you. It can either do positive work, negative work, or zero work. Where will friction do zero work? Work done by friction during pure rolling will be 0. A body at rest can have mechanical energy, it seems. Kinetic energy will not be there. There is a possibility that potential energy may be there, guys. So first statement is wrong and second statement will be correct, guys. So statement A is incorrect and B is correct statement. Clear, everyone? So or no, all of you? Next question, let us see. A bus of mass 5 metric ton is pulled at a speed of 15 km per hour on a smooth inclination 1 in 10. What is the power of the engine, they are asking? So what is the mass given here? 5 metric ton. I have told you 1 metric ton is 10 cube kg or not, guys? This is given as 5000 kg. Right? It is pulled at a speed of, what is speed given, beta? Speed is given as 18 km per hour, which I can write it as 18 into 5 by 18. You will get it as 5 meter per second. Now please try to understand. It is pulled on an inclined plane, beta. Very simple logic again. Right? So here you see there is a bus which is being pulled. What are the forces that are going to act on the bus, guys? If you see one component, I'm going to get it as mg cos theta. Other component, I'm going to get it as mg sin theta. Mg cos theta is the action given by the bus on the incline. Right? Will incline keep quiet? No, it will give normal reaction. So in vertical direction, I can directly say that normal reaction will be equal to mg cos theta. So in order to pull this particular bus upwards, guys, I want to pull this bus upward. Do I need to counter mg sin theta force or not? Yes. So what is the power here involved? Right? I need to counter which force? Mg sin theta force. In order to make it move with some speed v, guys. And already inclination is given 1 in 10. So sin theta can be written as 1 by 10, guys. So what we can write this as? 5000 into 10. Sin theta is 1 by 10 into 5. So you can cancel out 10 and 10. You'll get it as 25. 25,000 watts I am getting. So will it be 25 kilowatt or not, guys? Yes or no? Is that clear, everyone? But where is the option? Option is only not there. 2.5 is given. Metric ton is 10 power 3 kg only, no? I think we have done that in laws of motion. A bus of mass 5000 kg is pulled at a speed 18 km per hour. Inclination is given 1 in 10. Answer should be 25 kilowatt, guys. Okay. Here also there is some mistake given. It should be 25 kilowatt. Understood, all of you?
So how did we got that sin theta value is 1 by, I mean, how did we know that sin theta?
इंक्लिनेशन ना भाई, एक अगर आप हॉरिजॉन्टल जा रहे हो उसमें इंक्लिनेशन 10 है. What is the meaning of inclination 1 in 10? You are moving 1 unit in horizontal direction. It means it is 10 units in inclined plane. Or if you are moving 1 unit in vertical direction, the inclination is 10 units. You see, you from here to here, it's a, whenever such concepts are there, you'll use that only. So when you move 1 unit in upward direction, how much is the inclination? 10 units again. That is the concept. 1 in 10 means 1 unit in vertical, 10 units along the incline.
Sir, but that shouldn't it be theta, but we are taking it as sin theta exactly as 1 by 10.
Small values you can take, no?
Okay, yes.
A body of mass 5 kg moves according to the relation power used by the body they're asking. So x value is given as t square plus 2t cube. Position is varying with time, guys. Can we find velocity? I'll get velocity as dx divided by dt, which will be, I'm directly writing it 2t plus 6t square. Now you know velocity. Can we find acceleration? Yes, which is dv divided by dt. I'll get it as 2 plus 12t. Okay. So what is velocity at t is equal to 2 seconds? 2 into 2 plus 6 into 2 square. 4 plus 2 square is 4. 4, 6, 24. 24 plus 4 will be 28 meter per second, guys. And what would be acceleration at t is equal to 2 seconds? You'll get it as 2 plus 12 into 2. You'll get it as 26 meter per second square. So what is the instantaneous power given as? It is given as force into velocity. I can write m into a into v. Mass is given as 5. Acceleration 26. This is 28. Whatever is the power, guys, you can solve for it, I guess. Clear, everyone? So no, 526 will be 130 you will get. 130 into 28. You can just solve for that. It will be more than 2880. I think 3640 should be the case. Clear, everyone? Yes or no? Let's come from the behind, guys. Work done by a conservative force in closed path. How much will be work done by conservative force in closed path? 0. Right? Next question. A ball of mass 2 kg is moving with speed 4 meter per second. It is moving only. They are not saying it is rolling, guys. Rolling will be different case and moving will be different. It is simply sliding, let us say. Okay. Spring of force constant. The maximum compression in this spring, they are saying. Now what will happen? Suppose if the block is moving, will it try to compress the spring or not? So I'll just draw the free body diagram here, right? So let us say initially it has some speed u. Now as soon as it strikes the spring, will it try to compress the spring or not? So when it is trying to compress the spring, what will spring try to do? It will exert a spring force. It will try to restore it back. So here in this situation, there is no spring force. But as soon as you compress it, spring will exert a force called as spring force, right? Which is opposite to direction of velocity. So here in this situation, what I can consider here, velocity will become v, which will be less than u, guys. Okay. And what we'll also assume, at this position, you will have spring force acting in this manner. It is an unbalanced force. Again, what are the other forces that will act? Weight will act, mg, and also what is going to act? Normal reaction is going to act, guys. Normal reaction and weight will cancel out each other. Spring force is unbalanced force over here. So in the direction of unbalanced force, we are going to have acceleration. And whenever velocity and acceleration are in opposite direction, object moves in the direction of velocity with decreasing speed, guys, till its velocity becomes 0. Clear? So here, what is the velocity of the object? Here, velocity of the object is 0. Here, how much is compression? There is no compression. Spring is in its natural position. In this case, guys, some x compression, let us say. Here, compression will be maximum, guys. Okay. So what is happening? As you are moving from natural position of the spring to maximum compression of the spring, speed of the block is decreasing. And elastic potential energy will increase, guys. So how will we solve such question here? What we can do is we can write loss in kinetic energy of block or ball will be equal to whatever loss in kinetic energy is there. How will it show up as, guys? It will show up as gain in elastic potential energy of spring. What is loss again? It is initial minus final. What is gain? Gain will always be final minus initial. You see, initially no elongation or compression. So initial potential energy will be 0. Finally, you don't have any velocity. The final kinetic energy of the block will be 0. So what will initial kinetic energy be, beta? Half mu square will be equal to half k x max square, guys. So from this we can cancel out half and half. So what are we going to get the value of x max square as? X max square, you will get it as m into u square divided by k. So what will x max value be? It will be u into root over m divided by k. It will be u into root over m divided by k. What is speed given? I think speed is given as 2 meter per second. Is there anything related to mass given, guys? 2 kgs. Achha. He has shown in the diagram 2 meter per second, but in the question they have given 4. So please take it as 4, guys. Mass is given as 2 kg and 128 is the spring constant. What we can consider here, the maximum compression in the spring will be equal to u value is 4 meter per second. Mass is given as 2 kg. Spring constant is 128. We can write it as 4 into root over 1 by 64, which will be 4 by 8. 0.5 meters will be the maximum compression in this spring. Very important question, guys. Right? Whenever an object is striking a spring, spring will compress. Speed of the block or the object will reduce, and kinetic energy of the block will be decreasing. Whatever decrease in kinetic energy is there, it will turn up as elastic potential energy of the spring. Clear, all of you? Understood, everyone? It's a very important question again. Let us see the other question. Just a second. Am I audible, all of you? Right. One more question of collisions again. Two masses 1 kg each move towards each other with speed 4 meter per second and 2 meter per second, collide and stick together. So whenever they are sticking together, which type of collision it is going to be, guys? Perfectly inelastic collision. So in any type of collision, what we can conserve? Momentum of the system will remain conserved. You see, let us see, 1 1 kg mass is moving with 4 meter per second along positive x, or let us say both are moving in same direction, guys. Sorry, they have given that they are moving towards each other. So if one is moving along positive x, the other will move along negative x. So what we can write here, I'll just draw the diagram over here. 1 kg mass with speed 4 meter per second, let us say, is moving along positive x direction. In the same manner, 1 kg mass with speed 2 meter per second is moving along negative x direction. So what is the initial momentum here? 1 into plus 4 plus 1 into minus 2. Finally also momentum has to be same, but finally they are going to move together, guys, with common speed. Let us say, obviously they will be moving along positive x direction. Let us say with speed u, guys. What we can write? 1 plus 1 into u. 4 minus 2, you will get it as 2 into u. So what is the common speed? 1 meter per second. They're asking us to find what is the final kinetic energy of the system. So what will be final kinetic energy of the system? Both the masses, 1 kg mass is moving with 1 square. The second object also is moving with 1 square only. So I'm going to get half plus half, which I'm going to get it as 1 joule, guys. Clear, everyone? Understood, all of you? What's up? Clear, everyone? Let us see the next question. A force of 1 Newton acts on a 1 kg mass for 1 second, which is initially at rest. In another case, 1 Newton force acts on 1 kg mass, which is initially at rest, and moves it through 1 meter. Two cases are there here. A force is acting for 1 second and force is acting through 1 meter, guys. What is the ratio of kinetic energy they are asking? Right, so let us solve that question. Force of 1 Newton acts on a 1 kg mass for 1 second. Automatically, initial speed is 0, force is a constant value. So what will I get the acceleration as on first mass? I'll get it as 1 by 1, which is 1 meter per second square. So I can apply V bar is U bar plus A bar into T. Initial velocity is anyhow 0. So I'll get the speed V1, I can take it as, for how much time? 1 second only it is acting. So I'll get 1 meter per second. So what is the kinetic energy in first case, beta? It will be half into mass is 1 into 1 square, which will be half joule. In second case also, the same 1 Newton force is acting, so it will give an acceleration of 1 meter per second square. But here they have given it is moving the object through 1 meter. So I will be applying V bar square will be U bar square plus 2A bar S bar, guys. Okay. So what I can write? V2 square will be, initially anyhow it is at rest. 2 into acceleration is 1, displacement is 1. So I got v2 square value as 2. So what I'll get v2 value as, I'll get it as root 2 meter per second. Okay. So what will our kinetic energy be, guys? The second kinetic energy, if we are finding out, will be half into 1 into root 2 square, which turns out to be 1 joule. They're asking us to find the ratio of first kinetic energy to second kinetic energy, which turns out to be half divided by 1, which will be 1:2. Understood, everyone? Clear, all of you? Yes or no? Let us see next question. What they have given here is a free falling body takes 6 seconds to reach the ground. 3 seconds after release, the percentage of retained potential energy to its initial potential energy, they are saying. Again, it's a very simple concept. As you are already aware, whenever an object is falling under the effect of gravity, right? So initially it is taking how much time to reach the ground? Let us say I'm releasing it at t is equal to 0. It is taking 6 seconds of time, guys. Okay, 6 seconds of time. So time of flight, we know. What is time of flight given as? Time of flight will be given as root over 2h by g. So I can write t square value will be 2h by g. So from this I'll get h value as half g t square, which is half into 10 into 6 square. So what is the height initially, beta? Initial height is 180 meters. 3 seconds after his release. And I've also told you what is the distance traveled in free fall in t seconds. It is half gt square, guys. So it will be half into 10 into 3 square. 90 by 2, you will get it as 45 meters, guys. So initially it is at how much distance? 180 meters above the ground. Now, after 3 seconds, it has covered how much distance, beta? It has covered 45 meters in downward direction. So automatically, at what height it is going to be? It will be at a height 135 meters. They're asking us to find what is the percentage of retained potential energy to its initial energy again. So what is final energy here? Final energy will be m into g into 135, or I can say 45 is how many parts of 180? 1/4 part or not, guys? So how much will be retained? 3/4 will be retained. Directly I can use this. So 75% of the energy we can consider will be retained. Or you can write how much is retained, they are asking. So final energy we got. What is initial potential energy? Potential energy only they are saying. 180 we got. Yes or no? What is the percentage retained? You can simply divide. What are we going to get? mg and mg will get cancelled out. So 45 threes by 4. So UF divided by UI into 100, if you do, you will get this as 75%. Clear, everyone? Understood, all of you? Hope it is clear. Everyone, let's see one more question. A ball, which is the last question, guys. A ball moving with certain velocity collides head on with another velocity, another body of same mass at rest. If the coefficient of restitution is 3 by 4, the first ball is moving with some speed, let us say u. Second ball, initial velocity will be 0. Coefficient of restitution is given as 3 by 4. After collision, what would be the ratio of their velocities they're asking? As I said you again, whenever any type of collision is given, we are simply going to conserve the linear momentum, write the equation for coefficient of restitution. Okay, what is coefficient of restitution? It is v2 bar minus v1 bar divided by u1 bar minus u2 bar. So what is coefficient of restitution given? 3 by 4. Let us say it is v2. Both are moving in same direction. This you can take it as u. Initial velocity of second object is 0, guys. What I can write? 3u value will be 4v2 minus 4v1. Clear, all of you? What are we going to get here? U value I can take it as 4 by 3 into V2 minus V1. This is from coefficient of restitution. Next, what we can do? We can conserve the momentum, guys. Yes or no? So initially, both are identical masses have been given. So I can write m into u plus m into 0 will be equal to m into v1 plus m into v2. So I can write m into u will be m into v1 plus v2. So I'll get u value as v1 plus v2, guys. So as you can see, left hand sides of both the equations are same. Can I equate the right hand sides or not? So 4 by 3 v2 minus v1, you will get it as v1 plus v2, which turns out to be 4 v2 minus 4 v1 will be equal to 3 v1 plus 3 v2. So I'm going to get v2 value as 7 v1 implies v1 by v2 value will be 1 by 7. Clear everyone? Understood all of you? Right, so any equation, any collision equation may be given or any collision question may be given. What are we going to do? Simply write the equation for coefficient of restitution and conserve the linear momentum. Understood all of you? Clear everyone? I hope it is clear, guys. So these were the questions that I thought of discussing from work energy power, although lot of questions are there in work energy power, but because of time constraint, right, we will not be able to do. However, the exam whatever we will be conducting, in that if you have any doubts, we can discuss that, guys. Okay, so here I have not take the. So some people have sent me questions. What I'll do is I will send the solution. I hope these questions are clear, everyone. Right. Let us see one question from laws of motion. In a pulley block system at a given instant. So it's a very simple logic, guys. So we have constrained motion over here. We have 3 pulleys given, guys. One pulley is like this, right? Another pulley is like this. All the pulleys are massless only. Okay, we have a string passing over one of the pulley. Then again, it is going to pass over another pulley. So overall, as you can see, we have only one string directly connected, guys. Okay. So there is one more small pulley over here. Right, you can take. So this is one of the string, first string you can take. You can assume this is second string. Right, you can also imagine there is one more string beta. This you can take it as third string. Okay, and these are connected to some blocks. This you can take to be block A. This you can consider block B. Right, they have given block A is moving down with velocity 2.5 meter per second. So this is moving down with velocity 2.5 meter per second. What is the velocity of block B? They are asking, guys. Okay, right. Those who have doubts, please send their questions. Right. I will try to share the solutions by tomorrow afternoon or tomorrow evening, guys. Directly, I'll share it to you people. Okay. 2.5 meter per second is given. Let us try doing it, guys. Now, if you see, if this particular block is moving down, so automatically, can I come to a conclusion that, right, this is directly connected. So this will move down with same 2.5 meter per second. Also, this is going to move down with 2.5 meter per second. Okay, so I'll assume this as u, guys. Imagine this to be u. So what I can tell, beta, this is going to move down with u. This is also going to move down with u only. Now here, this is a fixed pulley. what should its velocity be? 0. It should not be moving, guys. So if this end is moving down with speed u, automatically the other end should move with speed u in upward direction. What do we use here? Velocity of the pulley will be v1 bar plus v2 bar divided by 2. Now you see, this pulley is moving down. Okay. So what I can write for this pulley, if I write the equation, it is moving down. So I'll take, and this end is moving up, guys. Okay. So what I'll write here, one end will be moving up, so I can write it as minus u. Let us say that this end is moving down with some speed v. So what I can write here, plus v divided by 2. So 2u will be minus u plus v. I'll get v value as 3u. So because we got positive, it means we have taken the direction correct. Again, you see this pulley is fixed, right? So it should not be moving. So if one end of the string is moving with speed v in downward direction, other end will be moving with speed v in upward direction. So will the block also move with speed v in upward direction. So 3 into 2.5, which you will get it as 7.5 meter per second. Clear? 7.5 meter per second in upward direction will be the answer for that. Clear, all of you? Right. I'll share the test paper, guys. I have not shared the test paper. I forgot, and because I was busy yesterday. Right. So I'll share the test paper in some time. Right. You please write laws of motion. Right. Motion in straight line, motion in plane, laws of motion paper. It is going to be a moderate paper. All question papers, all questions that I'm discussing are easy to moderate only. I'm not discussing difficult questions at all, guys. Okay. Right. So I would request you people to please complete writing that test by tomorrow, so that whatever doubts are there in that test, we can clear them. And tomorrow we'll start system of particles. Tomorrow and day after tomorrow we'll do system of particles. Day after tomorrow again you can write a test based on work energy, power and system of particles. Right. Later on Sunday we will discuss gravitation and units and measurements. Sunday would be a long class, guys. Okay. So that's it from my end for today. We'll be meeting in tomorrow's class. Till then, take care, everyone. Thank you all. What all doubts are there, please send it to the WhatsApp, guys. WhatsApp, whatever Creative Column WhatsApp is, please send it. I will share the doubts by tomorrow afternoon or by tomorrow evening maximum. Okay. So, take
Also,
care, everyone. Yes, sir.
so could you explain that at least one question, sir, which I've sent?
Kaun sa question?
So a particle moving on x-axis has acceleration f at time t
Just a
given
second.
by
I need to check. I guess. Is the board visible?
yes, sir, it is.
Particle.
A particle moving on x-axis has acceleration f at time t given by f is equals to f naught into 1 minus small t by capital T, where f naught and capital T are constants. The particle at t is equal to 0 has 0 velocity.
Direct question, no? What is given? Acceleration is given. So instead of writing f, because you will just get confused, I'll take it as a. It will be a naught into 1 minus small t by capital T. Yes or no? At t is equal to 0, particle has 0 velocity. When acceleration is 0, what is particle velocity they are saying? So if acceleration is 0, what we can consider here? A naught into 1 minus small t divided by capital T will be 0 or not? 1 minus small t by capital T will be 0. Implies 1 will be small t divided by capital T. So at what time they are asking? At capital T time, what is the velocity they are asking? Because this is acceleration, can I write it as dv by dt? dv by dt will be a naught into 1 minus small t divided by capital T. What will I get dv value as? A naught minus a naught into small t divided by capital T into dt. Now differentiation is there. In order to remove differentiation, will apply integration. At t is equal to 0, already velocity is given as 0. At t is equal to capital T, what is the velocity they are asking? What is integral dv? V. From where to where? 0 to v. A naught is a constant value. You will get integral dt as t from 0 to capital T. A naught by capital T is a constant value. Integral t will become t square divided by 2 from 0 to capital T. Right. So what are we going to get from this? you will be obtaining V value will be A naught into, you will get capital T minus A naught by 2, you will get this as capital T square divided by 2, which will be A naught into T minus A naught into T divided by 2, which is half into A naught into T. Clear?
Yes, sir.
Understood all of you?
सब एस्केलेटर वाला है बता दोगे?
वो भी तो इजी क्वेश्चन ही है, एस्केलेटर कुछ नहीं है, आप बेसिक से सोचो. Length it has to cover. If only person is moving, let us say he is taking time t1. So if person is moving, what will be the time? L by V. If only escalator is moving, let us say it is taking time t2. Escalator is moving with speed u, let us say. So what will I get time t2 as? L by u. If both are moving, I will reach quickly. So the speed will be v plus u. So what is the time in that case? It will be L divided by v plus u.
Yes, sir. Clear.
Understood?
Yes, sir.
Understood?
Yes, sir.
I have to cover length. From one point, from ground, I have to go to first floor. Length will be same. Along the escalator, length will be same. If only I am moving with some speed v, time will be L by v. If only escalator is taking me, time will be L by u. If both escalator and I am moving, time will be L divided by v plus u.
Yes, sir. Clear.
Ball falls vertically onto a floor with momentum p, then bounces repeatedly. The coefficient of restitution is 1 by 2. Total momentum imparted by the ball to the floor. Again, it will make use of geometric progression here. Total momentum imparted, total impulse imparted they should give. So initially it is hitting with momentum p. So what will happen now? It will rebound with momentum ep. Again it will hit with momentum ep. It will rebound with e square into p. Again it will hit with e square p. It will rebound with e power 3 into p. Like that it will go on continuing again. So what they are saying, a ball falls vertically onto a floor with momentum, then bounces repeatedly. This is the first time it will collide. Second time, third time, sorry. Here you will have second time, this will be third time, like that, fourth time, so on. The total momentum imparted by the ball to the floor. So you see, first what has happened? It gave P, then it gave EP, then it gave, so what is the impulse imparted? Impulse is nothing but change in momentum or not. So in first case, what is the impulse imparted by the wall? If I say it is EP minus P, yes or no? Or I can write this is impulse imparted by the floor on the ball. So what will be the impulse imparted by the ball on the floor? Can I say it is P minus EP? Yes or no? In second collision, what will be the impulse imparted? Will it be EP minus E square P? In third collision, what will I get? It will be how much beta? E square P minus E cube P. Like that, so on till fourth collision, it will go on or not. So what is happening here? They're asking us the total momentum imparted by the ball to the floor. I think, see again, you can take only these things also. So you can take only this. It is going and hitting P, EP, E square P. So this is the momentum imparted. P, EP, E square P, and E cube P, so on. So if you take P common, I will get 1 plus E square plus E cube plus so on, which will be geometric progression of infinite terms. 1 divided by 1 minus E you will get, which is common ratio. So P into 1 divided by 1 minus 1 by 2 you will get, which turns out to be P into 1 divided by 1 by 2. You will get it as 2P. Okay. What is it imparting? So when it is hitting, it will impart. No. When it is going up, when it is rebounding, it is not going to impart. It will impart only when it is hitting the floor. So P, EP, E square P, E cube P, so on. Okay. Right. So what we'll do, we'll discuss the other questions. What all doubts are there? Please just keep a text message in the morning, guys. Sir, some doubts I have sent. Please send the solution to this. Okay, please send a text message. I'll share the solutions to that. And yeah, so I'll share the paper also in some time, guys. Please solve that paper. Tomorrow we'll discuss the doubts in the paper also. Okay. So that's it from my end for today. We'll meet tomorrow. Till then, take care, everyone. Thank you all. Have all of you. Good night.
Thank you, sir.
Good night. Thank you.